Venn diagrams with three, let's spell three, events. Okay, so basically, when I talk about two events, or actually, I should instead of saying three events, let me just use the words that we're kind of using, three sets. So when we had two sets, our Venn diagrams typically looked like this, and this was the most common set right here. Or, of course, they could have looked like here. Oops, no, they can't go outside the region. And then we had sets that looked like this. So we had sets when it was a proper subset. So this is the, right here we have this is the viewing of a proper subset where B is a proper subset of A, which means that B is not the same as A, but has everything is matches. Everything that is in B is in A. We have this idea over here where we refer to as disjoint subsets, where A and B do not share any elements together. And then, of course, A is your the first one right here is your traditional Venn diagram where there is an intersection. And this was the one right up here that we pretty much worked on your entire homework. And it's very similar today as well. But you should understand these other two Venn diagrams from our notes and what to do with them. So now we're going to talk about three sets. Now that you got all that homework done and completed the assignment on three sets, sorry about that, on two sets that was due today, we're going to move to three sets. All right. So of course, this entire piece is our universal set. So we refer to the entire rectangle as our universal set. So just as a reminder, U is just the universal. And then we have our three sets. Now you can draw them in many different ways. I'm mostly going to draw them this way, where we have set A, set B, and set C. Okay. So this is our main image, and it's the image that we're going to work on in all of the parts today. Now, before we get into everything that we're going to be doing with is we're going to talk about, so we need to identify regions based on complements unions and intersections. And basically that's all I'm going to push you towards. Now we could do a lot of the other ones that we've talked about. We talked about the symmetric difference. We talked about the difference as well. Those we could do that, but I feel those ones get a little bit tricky, especially when we get to three. Maybe I'll put something in on your assessment of set theory that you can utilize that to maybe gain yourself a little extra credit of demonstrating your understanding. But in complements, unions, and intersections is something that you should be very comfortable in working with, at minimum. Now, in regards to if I some of these problems, and as we start in, will be the same thing. There's a third set around here, so there's a third set, but um, if I just ask you about the union or intersection of one or two sets, the answers are exactly the same as what we did on Thursday. You just ignore that there's this other circle. But I find that students have trouble understanding the circles. So with that, we're going to make, like I said, we're going to make a lot of these Venn diagrams, okay? We're going to make a lot of these circles, okay? So be prepared. Okay. You just want to have all three intersecting in some capacity. I can see that this one right here is a little too much, so I'll just adjust it just for the purposes of our notes, because then we're going to keep using this over and over. That's good enough. And I am going to copy this because we are going to draw many of these over and over and over. All right. So this is the basis of what we are working with. All right. This is this is three set Venn diagram. Okay. So we're going to have the set/set relationship, and the region. So the first one is just making sure that we understand when I say set A, what is the region that I'm referring to? And I want to do the visuals on these ones. And the notes, the predominant part I'm going to do in the notes is the visual. And then towards the very end, we'll talk about how we will just, how the questions are going to look, which will look slightly different, but it's basically the same thing. So I think that's about good size. All right, can someone verbally explain to me what I'm referring to when I say set A? The circle A. The circle. Now, the entire circle or part of the circle? What is that? The entire circle. The entire circle. Good. Okay. What happened if I say this? That's everything that is not in B. Everything that is not in B. Perfect. So that's everything around B. Try to do my best to color it all in, but you know what? I didn't get an A in coloring when I was young. Interesting enough, my family is a family of artists. Ah, why are you doing that? Okay, doesn't like me to do that. I got a little way around it. So everything that's outside that circle. All right. So I want to make sure first and foremost that we understand that aspect. That when I talk about the set A, I'm talking about everything within that circle. So this is, this is basically three regions here. So um, there are a total of 8 regions. All right. There are a total of 8 sub regions here. If we were to actually just count them and put a dot inside each one, we have 1 on the outside, 2, 3, 4, 5, 6, 7, and 8. So the total of 8 little regions, okay? And most all of the sets that we're going to either talk about one of these regions or a collection of 2, 3, 4, up to all 8 regions. And we need to know which regions we are trying to identify in the set relationship. All right. So what about A union B? Give you a little time to try to paste this on your own. Tomorrow we're going to practice a little bit more. Tomorrow I'm going to have you actually, I know it's asynchronous, and I'm going to post this to be done asynchronously. If you think you can do it and complete it asynchronous, I'm going to have some of these regions just like this, and you're going to either attempt to color them in or show me what the answers are so that I can kind of check what we're doing. I wanted to do that a little bit more tomorrow so that we can spread out this material. And most of the questions, like I said, there's different ways we can talk about these regions with A, B, C in complements, and we should feel comfortable enough to do that. Now, when I ask for A and B, the best way to do this is to utilize, with unions, the best way to do these problems is just to color in exactly what you're looking for and do each piece. That's as easy as it is. All right. So so what is this going to look like?
Both circles of A and B.
Both circles of A and B. So if I were to do A would be here. Why did it do that? It's weird. Okay, so if I were to do A, be here. And if I did B, be here. And so the whole region of A union B would be where both of them, it would be both of them. So that is A union B. It'd be those two right there. And right now, I'm not doing anything different than what I did on Thursday. I'm just, there's a third circle that's in the image, but I hope you're seeing that even though there's a third circle, so far that idea of a third circle hasn't done anything to any of these problems. A here, what about this? What does this mean? What does this look like?
Is it going to be part of A and C, but not all of it?
Correct. And which part of it is going to be?
B.
There's no part of C. No, there's nothing in C. We can ignore C.
I say B.
It's not B.
It's just going to be the little part.
It's going to be the little part. How many regions are there? One or two or three or four?
One they share gonna be the purple part between A and B.
This is A and C though. This is not A and B.
See.
Stop getting your mind out of B. Get your mind out of B.
Sorry, it's just they sound the same. A and C.
So how many regions is this one? So the previous one up here, I want to point out the previous one up here was 1, 2, 3, 4, 5 regions.
Wow.
How many regions would this next question have?
Four. Just one.
No, it's a little bit more than one. Definitely not
Three?
4. No, not 3.
Two.
It would just have 2 of these little regions.
4 and the little thing and
No, not 4. Not 4 regions. Just 2 regions. So when you're what is that?
nothing. Forget.
So when you're doing this, the best way to do these ones, if you're really doing this by practice, is using an eraser. When dealing with intersections, the best way to do it is using an eraser, and of course utilizing some different colors. You really want to do some stark color contrasting when you're doing these ones. So I want to do A. So here's A, right? And then I want to choose have a very drastic different color. And here's C. And so my answer to this problem, or you have them very, very slightly shaded, would be what is overlapping with each other. So then I want to make sure I do something, I might even use after I've done something with a pencil, I can either erase. So I'm going to look for what's been intersected, which would be here.
Oh my god, that was what I said.
You said 4 regions.
Exactly, 4. That thing over there, it's 4. You name it right there.
I never did. No, I didn't.
Okay.
And then use an eraser, and we have that, right? Boom. So you got to see how I did that in terms of the erasing as well. But there's only the 2 regions that were in this problem. There's the 2 regions that make up this one. All right. This one had 5 regions. Or whatever. 1, 2, 3, 4, 5. Yeah. Oh, actually, this one had 6 regions. Jeez. Boop. And this one has 2 regions on the intersection. So when you're doing intersections, you got to think about where they overlap. It's the overlapping part of them. So with unions, combine, when talking about the Venn diagrams, with intersections, you have to look at the overlap. Okay. Set/set relationship. I'm just going on to a new page, so I'm rewriting it. And the Venn diagram. So the next one now is A union this. What does that mean?
The union between A and whatever is not on B.
Yeah, so not B or not B or the complement of B. However you want to say it. So A, we've gotten that down pat, I think. We got A right there, boom. Now not B, now once again we're going to do it. We're going to do not B, which is everything outside of B. Right there. Get that nice and colored in. All the little empty spots here. And so it's this combined. So my answer includes all of this right here. Everything that is not in white is my answer. So the whole thing is my answer right there. So I included A plus. Now the only real part that it adds, so I want you to note that it added these two little small regions right here. So when I combined them, if I just thought of not B or the complement of B, it added these two little pieces right in here. Okay. What about the intersection of not B, the complement to B, and the complement of C? Not B union not C.
Everything outside the both of them.
Everything outside the both of them combined. That's the tricky part. But yes, it's everything outside both circles. So we just take this 2 steps at a time. Outside circle A. So that's going to be include, since it's a union, I'm just going to have all that colored in, right? That's everything outside of A. Visually, it's very helpful for the purposes of notes to actually draw out the Venn diagrams. But in terms of asking the questions, it becomes a little bit like, ugh. So I asked them a slightly different way, as we'll show you. And everything outside circle B, everything outside B right there. So it's everything except that little piece right in the side, in the center. Does not include those ones right there. Which is really just the opposite of B intersect C, which is pretty interesting because that little piece inside there that's not colored is actually B intersect C. So there is a kind of a cool relationship between the complement union and the set intersection. They are in essence complements to themselves. What is that?
Nothing.
Okay. Let's try. And based on, since we have this image on top, it should be able to help us. But what is B prime intersection C prime? Okay. So now it's everything outside the circle of A and everything outside the circle of B. So if we can see that from our colors here, it's whatever's really dark because everything that's dark meant double, it was double layered. So from our previous, it's outside the circle of A, so it's outside of A and it's outside of B. So the intersection of not A and not B is everything out. Oh, oops. Well, I'll change. I got to change the problem. Sorry about that. This, I gotta change this. Sorry. Did I do it to the other one too? Yeah, I did it to the previous one. Sorry if I confused you. I'm so sorry if I confused you. In both of these, it works with A and B. It was not supposed to include C. I'm sorry. So let me just go over that understanding. What I had drawn was outside circle A and outside circle B, not outside circle C's. I think I heard someone say B, and then it threw me off. I think someone said outside the circle B, and then it threw me off, and I included B, where I was pointing to try to do C. But both of these ones would be, that would be the union of, the entire thing would be the union of A and not A and not B. And this part would be the intersection of not A and not B. It's where it's much darker.
I don't get it because
Mm-hmm.
the second to last one, it's shaded in both circles and outside, but then the second one is just the outside.
Correct. So intersection means what was colored for both of them. So what got colored for both? So this part out here, this part right here is part of not A because it's outside the circle of A. And this part here is not B because it's outside of B. So first and foremost, this part of the region, you can see how the reason why this out here is part of not A and not B because it's not included in A and it's not included in B. It was outside, and that's why over here you can note this because it's darker purple. So we have a light purple, a blue, and then we had a dark purple out here. Anything that's technically dark purple meant that it was colored on both of the drawings. It was colored for not A and it was colored for not B. And that's what we're looking at with the intersection. Same thing with this region right in here. This region, once again, is outside the circle of A and it's outside the circle of B. So anything that's combined, that when I was shading them, that's what I go with. So when I was shading not A, basically when I shaded not A, this is what it looked like, right? So it had all that stuff that was not A, everything outside that circle. And then when I was doing not B, it was everything outside here. But I want the region that's in both of those that was not included, that was included in both of those, which is this purple area that is shaded right there. Basically, if I had drawn the same image as I drew up here, then I would have erased anything on its own color. So let me try one more time. Let me try just another visualization of showing you. So not A. Let me try a different color. Not A. Hey, don't do that to me. Technology got a little fancy on me and it was like, oh, let me make that into a circle. No, no. So here's not A. All right, do we see how that's not A? And then not B. And let me do a little darker. Green. Not B. And so what is not colored, what is colored differently, the intersection is what's really dark. You can see that darker area, that's the intersection. So basically now I would just erase what is in common. And what I'm left with is not A, not B. So a couple of just different ways to think about them. I just need to note which part of the regions I'm referring to. Okay. So as you can see, the coloring of them is getting a little bit more and more difficult. So what we're going to do now is we're going to switch to something that makes it look like a little bit more like how your homework is going to look at. And now I'm going to state the cardinality of each region. Okay. So this will look slightly different, but it's really just the same. So we have our regions, but I'm also going to include some numbers in here. And I want to make sure these numbers are different from each other. So we'll say this is 2, that this is 3, this is 8, this is 4, this is 9, this is 20, this is 11, and this is 5. Now, this isn't the name of the region. Each of the numbers represents the cardinality of that region, the number of elements. In the homework due today and the previous homework, I wrote out all of the actual elements, and in that homework, you had to identify the exact elements that were common and within each one. You had, there were like A, B's, and C's, and there was actually some numbers, and then there was even some words. In this one, I'm just saying straight up, these numbers right here don't represent the set. Like, that isn't just the set of 3. There's 3 elements. Now, those elements could be people. Those elements could be animals. Those elements could be numbers or letters. But that's what we have. So this will help us in a sense, this will help us without having to do the drawing. So this is what we're going to be using for these next problems, okay? So you're going to have to do some addition. Okay. So the set question, the Venn diagram, and actually, you know what? In this case, I'm gonna do it a little bit different. Yeah, I want to just do this a little bit different. Okay, so for all of the problems, we're going to use this one right here. For all the problems that we're doing, we're going to use this right here. This is what we're using right there. And I'm going to ask you for the cardinality, set relation, the question, and then, of course, the answer. So if I were to ask you, and so we're going to have this little part right here, n parentheses. All right. Now this means the cardinality. This is another notation for cardinality. It means to count, basically count the numbers in the selected regions. Okay, select a number in the selected region. So for example, let's do one that we just did, A intersection B. Okay, so we want A, what is intersected with A and B. So that's what's in both circles, A and B. Okay, and which ones are those ones? Which numbers are in both circle A and in circle B?
8 and 9.
8 and 9. So you can see that it's this piece right in here. This is what it's in both 8 circle A and it's in circle B. So my answer that I'm looking for you, and this is how you're going to do your homework, the answer that I would look
Mister,
for.
it's also in circle C, is it not?
But yeah, but we're not caring about circle C. The question is about circle A and circle B.
So then why'd you put 9?
Because
I mean, why did you say 9 also?
Because 9 is also in circle A and circle B. I didn't say anything about, you can almost ignore that there's another circle there if it's not in the question. So it doesn't say anything about the question itself that I'm asking you right here does not ask you about circle C. So we don't have to worry about circle C when thinking about our solution. We're asking ourselves in this question, what's inside circle A and what's inside circle B? I get this region right in here. That's right, that's the same thing. Now there's element C, but what we're asking about is what is in A, set A, and what is in set B. So my answer that I want you to work on is, and I want you to show the work, is 8 plus 9, which is 17. Okay. Next question. A union C. I want everything that is in circle A along with everything that is inside circle C. Okay. So I want everything that's in circle A combined with everything that's in circle C. Now, if it's also included in circle B, that's irrelevant. If it's in B or not in B is irrelevant because that is not in this question. So what's my answer? How do I show? While showing my work, it would be?
Is it 4 and 9?
It's a lot more. That would be the intersection. This is the union. Everything that's in both of them.
So it'll be all that is in A plus all that is on C.
So what is it?
1, 3, 8, 9, 4 plus 20.
Finish it.
And 4
plus 11.
plus 11. Sorry, I cannot see it well.
Okay, plus the 11. So we counted everything that was in both of them, not just the intersection is only the overlap, and we have to do this math. So does that 11 plus 11, 22, or 11 plus 4 is 15, plus 20, 35, plus 20, so I get 55. Okay. Now I know I haven't really done all three, so now let's do a problem that has all three. What about A intersection B intersection C? So now we're adding 3 of them. Now when you're doing these, you can actually add parentheses as you wish. So we can add an extra, we can say, we can think of this as A intersection with B intersection C. So when you can write the parentheses, I always work from right to left when I do these problems. you can work from left to right, you'll get the same exact answers. So we want to look at the B intersection C, and then also what it intersects with A. So what is, can anybody, and actually the answer is just one single answer. What is the intersection of A, B, and C?
9.
It's just 9. And I meant to erase this colors. It's only 9. This region right here is the region that is intersected by all 3. It's intersected by A, it's in circle A, it's also in circle B, and it's in circle C. So now this is an example of a problem that is now utilizing all 3 sets. Okay? So the answer here, oops, is 9. Okay? Last one for today. A intersection B union C prime. And I know these ones are going to get a little bit more difficult. We're going to spend more time tomorrow going through more of these practices. You can do it asynchronously if you feel comfortable and just be answering the questions. Or you can stay in class if you're having trouble with them so that you can participate. So I want everything that's in these circles. So it could also be, it's to your benefit to redraw these. And in your homework, you'll have a copy of them right next to each problem, just in case, so that you want to do that. Oops. Let me erase that color piece in there and then copy paste. This will be our last problem. For today. All right, so first off, let's find B union C prime. That is everything that is in the circle of B combined with everything outside the circle of C. Okay?
Should be then everything that is on B plus, everything that is on both A and C.
No. Well, no, the first thing we're going to do is this piece right in here. So let's first take care of this right here. B union C. And so that means we're inside the circle of B. So it's everything here. And it's outside the circle of C. And it's outside the circle of C.
Also, we add in B plus 3 plus, do you add the 2?
No, because we haven't finished the problem yet. This is how we're starting. These problems require more steps.
Yeah, just taking the first step.
And now we're going to do the intersect. We're going to intersect that with A. So what do we have here that is also in A? It has to be inside A. So we only are going to include what is also inside A. And so inside A is this right here. So what was overlapped? So the intersection, it means that we only want what was in our current region as well as being inside A. So what is also what of the region I shaded is inside A?
9 and 8.
So
3.
and 3. So my answer to this problem would be this region right here. is also inside there. And so my answer would be 3 plus 8 plus the 9, which is 20. It was. So we'll take more time practicing those tomorrow. Take the time to really, especially these last two problems, to grasp those. We're going to elaborate on those two tomorrow. We're going to start doing we're going to do a few more of the 3, and then we'll have the homework assigned tomorrow. So we're going to try to do it a lot more interactive. I'm going to be we're going to do it on Nearpod tomorrow. Give you a heads up, Nearpod tomorrow, which means I'm going to be expecting each of you to attempt to be drawing or identifying, showing your work, so I can see both who's active and who's, you got to make that attempt to do them. That's what I have for you to hear. There's no homework tonight. The homework is assigned tomorrow. See you tomorrow.